Hello and welcome. My name is Mustafa Tokat. I am software developer. In this video, I will introduce you to VoxMed, a voice-assisted reporting system for healthcare. You will see how it was born, what real-world problems it solves, and why its architecture is fundamentally different from traditional methods. A journey of 3 parts awaits you. Part 1. The story of VoxMed. How did it start? Which real problems did we set out to solve? And why do hospitals, doctors, and healthcare professionals truly need something more than just another dictation system? Part 2. The technical behind the scenes. I will explain my engineering decisions, why an asynchronous queue, why Python, why a 3-tier filtration architecture instead of a single powerful AI module, which mistakes did I make, and which decisions saved me. Part 3. We will dive into the leaf system together. We will take a voice recording, process it, run it through the AI pipeline, and instantly see the final medical report. Let's start with part 1. This slide tells the origin story of VoxMed. The idea came directly from hospital information system developers who solve systemic failures in hospitals every day. The main bottleneck is massive reporting backlogs that paralyze daily operations. When reports are not typed, a domino effect starts: delayed patient treatments and blocked government reimbursements. In Turkey, without a final report, the Social Security institution does not pay the hospital. This creates a huge financial and clinical burden. Today, a single medical report takes between 15 and 30 minutes to complete. The graphic shows this time loss clearly, and there is a major quality flaw. High error rates are inherent to manual transcription and formatting. Doctor must dictate, then wait for transcription, then check every word, correct grammar, and fix Latin or Turkish medical terms. This slow process leads to backlogs, and backlogs lead to delayed care. This slide highlights the full financial magnitude of the problem. In Turkey, no report means no payment from the Social Security institution. For an average-sized hospital, the annual loss due to delayed or missing reports alone can exceed $500,000. But that is not the only cost. Hospitals also employ large teams of medical secretaries, between 15 and 45 people depending on the hospital size, just for manual transcription and formatting. When you add these personal costs to the reimbursement losses, the total annual financial impact easily exceeds $1 million for an average hospital. These are not small inefficiencies, they are direct revenue and operational leaks. On the left, the current state: a claustrophobic closet. Traditional dictation systems are expensive, clunky, and hypersensitive to noise. They force doctors to leave patient care and hide in soundproof rooms just to get a clean recording. They also struggle with Turkish medical terminology. On the right, the VoxMed ideal: open and integrated. Doctors belong in active patient care, not in closets. VoxMed works anywhere, on any device, without special hardware or silent rooms. This slide is about the most serious consequence: patient safety. When reports are delayed for weeks, treatment decisions are postponed. A patient's critical finding might sit unread. This not only harms the patient but also creates legal liability for the hospital and the physician. In our research, some hospitals take weeks to deliver a radiology report. That delay is unacceptable. VoxMed eliminates backlogs, so reports are ready in seconds, not weeks. This table shows the direct comparison. Traditional dictation takes 15 to 30 minutes per report. Expensive hardware, silent room only, low accuracy for Turkish and Latin terms, and manual formatting. VoxMed less than 1 minute. Device agnostic. phone, tablet, web, WhatsApp, works anywhere, autocorrects medical terminology, and auto-templates to hospital standards. The result is end-to-end reporting in under 60 seconds. This is not just an improvement, it is a paradigm shift. VoxMed integrates directly with hospital information systems. Once a report is approved, it's sent automatically to the HIS system. Because the report is ready immediately, the hospital can submit it to the Social Security institution without delay. This permanently plugs the reimbursement leaks that cost hospital hundreds of thousands of dollars each year. No more manual data entry, no more lost claims. VoxMed is not just a dictation tool. It has an embedded DICOM viewer. Radiologists and clinicians can view medical images directly inside the platform. The system can list findings from the image, allow the doctor to select relevant ones, and add them to the report with one click. It also reads measurements and drawing areas. This saves even more time and reduces manual errors. The doctor simply focuses on what they are looking for. The system handles the rest. VoxMed is built for enterprise scale. It offers an API for seamless integration with existing health IT systems, so any health informatics company can add value to their solutions. Automated routing sends reports to the right physician, assistant, or department without manual intervention. This value waterfall summarizes everything. VoxMed eliminates backlogs, which means faster treatment, lower administrative costs, and no reimbursements delays. Hospitals can reduce or even eliminate medical secretary transcription teams. One hospital may have 15 to 45 people just for reporting. By automating the entire workflow, the average hospital gains more than $1 million per year. But more importantly, patients get their results in seconds, not weeks. Better for the wallet, better for the doctors, and vastly safer for the patients. Now we can talk about technical behind the scenes. I designed this system like a real assembly line. Each station has a single responsibility. Voice capture knows nothing about AI. AI knows nothing about reporting. They communicate only through standard JSON schemas. I could have used microservices, but that would add unnecessary complexity. Instead, I kept everything in a single monorepo. I chose Python over PHP. Python gives me better AI library integration, simpler deployment, lower execution cost, and hospitals can run it on-premise without problems. I made every module an isolated agent. The voice agent has no idea the AI agent exists. They never call each other directly. They push jobs into an asynchronous queue. The code that receives the job is completely separate from the code that executes the job. This means I can change, upgrade, or even crash one agent without losing the job. All communication follows a strict JSON schema, no hidden dependencies. When traffic spikes, the queue simply grows. Nothing crashes. If a module fails, the job stays safe in the queue. I scale the system by changing one environment variable. I spin up more workers. They run the same code and pull from the same queue. No code change required. Each input channel, web, WhatsApp, email, API, has its own entry point. A failure in one channel never affects the others. This gives me real isolation. Every task that enters my system receives a unique persistent job ID. When something fails, I run a single query and see exactly where it broke. Voice capture, preprocessing, AI call, template rendering, or distribution. All in one place. When a user reports an error, the system automatically sends that job ID to the support desk. I don't need to ask the user to reproduce the problem. I just pull the ID and debug. I set a rule for myself. Adding a new hospital requires zero new code. All critical settings live outside the code base. Templates, SMTP, terminology dictionaries, hospital integration details. They are managed through a web panel or environment files. A hospital wants its own acronyms or a different report layout. I don't touch the code. I just change the configuration. I initially believed one powerful LLM would be enough. I was wrong. Two big problems hit me. First, audio inputs came in many different formats, different codecs, bit rates, channels, some from WhatsApp, some from email. This directly reduced ASR accuracy. Second, a single LLM completely failed to understand local doctor slang, inconsistent acronyms, and outdated Turkish medical terminology. One model cannot learn every hospital's unique dialect. I had to rethink my approach. I built a three-layer solution. Layer 1 is a custom Turkish medical dictionary for instant deterministic term matching, cheap and fast. Layer 2 is a low-cost LLM like DeepSeek for bulk text cleaning and generic normalization. Layer 3 is a powerful, expensive LLM reserved only for final report generation, low volume, high stakes. This tiered filtration prevents wasting expensive compute on trivial tasks. The architecture works. I stopped trying to solve everything with code. I built a web panel where doctors and secretaries can enter their own local slang, acronyms, and all Turkish terms. No waiting for a sprint, no code deployment. I turned domain experts into part of the system. They fix terminology themselves. After I added the web-managed dictionaries, terminology errors dropped by over 90%. The pipeline now adapts to each hospital's unique dialect instantly without a single line of new code from me. The combination of deterministic dictionary lookup, cheap LLM cleaning, and powerful LLM generation turned a fragile system into a robust one. Hospital appreciated controlling their own terms. If I started over today, I will not begin with a single powerful LLM. That was my mistake. I will implement the three-tier architecture on day one. Retrofitting it later required painful refactoring and delayed customer dictionary management. The lesson is clear. No single AI module, no matter how powerful, can learn every hospital's local quirks without localized dictionaries. Two decisions were absolutely flawless. First, the asynchronous job queue. It's guaranteed that no task ever gets lost even when modules crash or traffic spikes. Second, the persistent job ID logging. Complete observability from voice capture to distribution in a single query. These two pillars, resilience and visibility, saved the system during rapid scaling. I will keep them exactly the same. Now I will introduce you to VoxMed interface. I must apologize that the interface has not yet been translated into English, so I'm using Google Translate tool. Assuming you have limited time, I won't go into every detail, but when you have time, I will be happy to explain it thoroughly. Now let's look at my system. There are three user types in the system: admin, doctor, and medical secretary. We'll log in as admin. When we first enter the system, we are greeted by two sections: voice recording section and audio file upload section. At the top, the microphone and microphone audio settings can be adjusted. If they wish, doctors can record audio here or upload existing audio files to the system. Below, there are sections for selecting a doctor and medical secretary. If a doctor logs into their account, the doctor field comes automatically selected. As for medical secretary section, If the doctor is busy and there is a medical secretary registered in the system, the report is sent to that secretary for review and finalization. If the doctor does not select a secretary, the report is transferred to the doctor's own report box. In this section, the doctor can see which medical secretaries are online and what their workload is. When you click Create Report, the relevant audio recording is processed and the report is sent to the My Reports section for final approval. Now I want to perform an operation on a real report. Now you will listen to a real doctor's recording. In this recording, the doctor is performing contrast-enhanced wall abdomen and contrast-enhanced trauma imaging evaluations for multiple patients. Naturally, while speaking, the doctor makes mistakes, corrects himself, restarts sentences, and uses inverted word order. This is because he expects a medical secretary to create a report from these notes. He is only providing the evaluations. Normally, without VoxMed, the medical secretary will need to rewind and fast forward through the recording, identify all the findings, and write them into a report. This process takes between 15 and 30 minutes. For example, this particular recording contains 2 patients, so converting it into a report takes about 30 minutes. In some recording, there can up to 10 patient reports. VoxMed understands the doctor contextually. It ignores the incorrect statements, keeps only the corrections, fixes any Latin terminology if present, analyzes the sentences grammatically, rearranges them, and produces a medically flawless report. Now let them upload the relevant file and see how an evaluation turns into a medical report. First, let me play a recording for you. Sorry, I don't have any original English recording, so I will play a Turkish recording instead.
22-15-402 Volkan Çiçek hastanın 23 Mart'ta çekilen tüm abdomen BT'si var, kontrast madde var. Karaciğer sol lob sol epikondürme uzanım göstermektedir. Karaciğer CC uzunluğu 216 mm normalden büyük ölçülmüştür. Karaciğer parenkiminde hepatostatos sekonder difüz dansda azalması izlendi. Dalak hilus komşuluğunda 14 mm batlı aksuar dalak ile uyumlu görünüm izlendi. Hasta erkek hasta uterus miyometriumla ilgili cümleler varsa silelim. Prostat boyutu aksiyel planda 46x41 mm ölçülmüştür diyelim. Paraortik parakaval alanlarda kısa aksı 1 santimi geçmeyen
I don't want to make it too long. Now let's send the recording to the system. Okay, select file. And I think this file, yes. Okay. Let's select the doctor and medical secretary. Adim Karaman. Burcu Kartal. And let's create our report. Okay, the voice is being transcribed. Draft reports are being created. Final reports are being prepared. And the report is complete. And we are on my report section right now. Here is our generated report. It's in the first row. In the action section, there are 5 buttons. Let me explain each one. Edit button. If you click this, you can go into the details of the audio recording and review it. TXT button. If you click this, it gives you the raw transcription of the audio recording. Dojix button. If you click this, you can download all the reports from that audio reporting in Dojix format. Zip button. If you click this, you can download a zip file. Inside that zip file, you get the audio file, the raw transcription, and all the generated reports. Everything is organized in folders. This way, we keep all records together. You don't have problems like where is the report, where is the audio. This feature was actually requested by people in the field, because in legal disputes, lost files cause serious trouble. Delete button. This button is only available for the admin. Now, if you click the edit button, you can see the reports that the system has finalized. Inside that edit screen, view button, if you click this, the doctor or medical secretary can see the final version of the report. Confirm button. If you click this, you can send the report directly to the hospital management system. Dojix button. If you click this, you can download the report in Dojix format. Print button. If you click this, you can send the report to the printer. Copy button. If you click this, you can copy the report to the clipboard. Share button. If you click this, you can share the report via WhatsApp. Assistants sometimes need to send it to their supervisors to ask for advice. Delete button. If you click this, you can delete the report. Add new patient report button. If you run into any problem, you can click this to create a new report manually. If the doctor or medical secretary uses the edit button, they can make changes to the report that the system has created. Let me explain how this edit screen is laid out. On the left side at the top, you can listen to the related recording again while you work.
Dalak Hilus komşuluğunda 14 milimebatlı aksuar dalak uyumlu görünüm izlendi. Hasta erkek hasta uterus miyometriumla ilgili cümleler varsa silelim. Prostat boyutu aksiyel planda 46 çarpı 41 milim ölçülmüştür diyelim.
On the left side at the bottom, there is a draft report. This draft report only contains the pathologies that the doctor mentioned in the audio recording. Also, at the bottom left corner, there is a robot icon. If you click on it, you can reach the VoxMed radiology assistant and ask your questions. This assistant knows the content of the report and can directly make changes to the report content. On the right side, you see the final report that has been created. Areas highlighted in red show the pathologies that the doctor mentioned in his speech. This is for quick review. Now, how does the system work? It automatically understands which report the doctor is reading from the audio file, and it brings the correct template. Then it places the pathologies into the appropriate places in that template according to the anatomy. If doctor or medical secretary wants to make any changes, they can do so right here on the right side in the final report. From here, they can also approve the report and send in directly to the hospital management system. Or, if there is any problem with the report, they can create a support request. If there are other reports related to this recording, they can navigate between them. They can also translate the report into any language in the world. To not delay the video, let me quickly explain how to write a report using DICOM. The system also has embedded DICOM Viewer. This part is only visible to doctors. You can examine any MRI or CT image with AI support, make measurements, and create a report. On the top left side, there is also a voice recording section. Doctors can record their voice here and create reports from the voice recording as well. There are also tools available for making measurements and markings on the images. On the bottom right side, there is a robot icon. Doctors can click on it to reach the VoxMed DICOM assistant and ask questions about the relevant image. The assistant also detects the marked and measured areas. It understands which areas have been marked and measured. On the left side, there is an AI report button. From there, doctors can examine the uploaded images with the help of AI and create quick reports based on AI findings and suggestions. Kyle, you asked for 10-minute video, but I could only explain this much at minimum. If you have any other questions, I will be happy to answer them. Thank for your valuable time.